Hey everybody, it's Dr. J, and today we are talking about conversion factors from chemical formulas. So let's talk about some chemistry, all right? So we looked and talked about mass percentage, right? And this is a way that we can understand how much of our elements is in our compound. But another way to understand that is by just literally looking at our chemical formula, right? So chemical formulas can tell us a relationship between our atoms and molecules. And you want to know how it's able to do that? By that key word that is called moles. Yes, moles. I told y'all. Moles is something that you want to understand. Okay, so please start understanding moles. Now, specifically, let's talk about it, right? So let's talk about water. If you understand, right, for every 1 mole of water, right, with this is always going to give us, moles give us a ratio. Basically, it's always going to give us a ratio, right? And with mass percent, that's a ratio in its own self, but if we can just determine the ratio literally by looking at the chemical formula. So if I'm looking at water, H2O, right, I need to understand that in H2O, 1 mole of water, right, that means that I have 2 moles of hydrogen. So how can we use this towards our benefit? Okay. So let's look at an example here. What is the mass of carbon in grams? All right, what is the mass of carbon in grams if you have 20 grams of glucose? Once again, glucose, if you didn't know, right, C6H12O6. So we got 6 carbons, 12 hydrogens, 6 oxygens. Now, of course, right, we can use mass percent. I'm not saying that's like not the wrong way to do it. All right, that's perfectly fine to do. Right, we understand mass percent. Look at that mass percent video if you want me to talk about mass percent. We're not talking about mass percent today. We're talking about conversion factors from chemical formulas. So how are we going to use this technique today, Dr. J? Woo! Let's look at it. All right, so this is going to show that ratio with those moles. Okay, so we're going to break this down. What do we always do? We always start off with our given. 20 grams of glucose. 20 grams of glucose here. All right? And remember, this is a dimensional analysis type of problem, so we understand 20 grams of glucose is just over 1. Okay, we understand that. What we want to do with these type of problems, and the reason why I suggest this way than the other mass percentage is a little bit more easier to me. All right, but 20 grams of your glucose, and we're going to convert that to moles. So we're going to convert it to moles. Now, if you remember, right, how do we convert grams to moles? We're going to use our molar mass of that compound. So just to remind everybody, the molar mass, right, you have to look at our periodic table. Okay, so in this case, if I want to convert grams of glucose to moles of glucose, I want to use this conversion factor here. 1 mole of glucose over grams of glucose. Now, how are we converting our grams to moles? We're using our molar mass, right? That's not going away, right? Y'all need to know moles and molar mass, right? This is key concepts, basic things that you got to understand in chemistry going forward. So you got to be able to convert your grams to moles quickly too. So let's go over that. Grams to moles, right? If I'm going from grams to moles, I know that my grams of glucose needs to be canceled out here. So that's the reason why we see grams of glucose on the bottom here. They need to get rid of each other, right? So they're going to be canceled here. And then the moles of glucose will be on top here, okay? Now, let's talk about the numbers, right? We understand the units, right? Grams need to cancel out. Moles is going to be on top. We get that. But where does the 1 and then where does the 180 come from? Well, I need to understand, right, molar mass. Molar mass is telling me that for every 1 mole of my compound, I have a certain grams of that amount, right? That mass of that amount. So basically, you're always going to have 1 mole equal to your grams, like in our conversion factors. Okay, so that's 1. 180, where did that come from? Well, this is coming from my compound. So I need to understand, right, that if I add up 6 carbons, 12 hydrogens, and 6 oxygens, this will give me 180, right? So basically, I'm going to do 6 times 12, because that's what we're getting from our periodic table with carbon. All right, so 6 times 12, 72, plus 1 times 12. So we got 12 hydrogens, and we have a 1 here because we're looking at our periodic table again. There's a 1. All right, so that's 72 plus 16, right? Because that's our oxygen. And then we need to multiply this by 6 because we have 6 oxygens. And that will give me, right, 180 when we add our carbons, hydrogens, and oxygens together. Okay. Now that we got that settled, grams cancel, we're in moles. What do we do here? Bam. This is the ratio step. Okay, so this is our mole to mole ratio step. And this is going to be very, 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 very important later on. Okay, but for now, we're going to use it this way. This mole to mole ratio step is telling me that for every 1 mole of glucose, there's 6 moles of carbon. Now, how do I know that? I'm looking directly at my chemical formula, right? I have 6 carbons, and I have to understand that this 6 can represent my ratio of moles, right? It could tell me that ratio by using our moles. So for every 1 mole of glucose, there's always going to be 6 moles of carbon, right? And if it's not 6 moles of carbon, then you have a different compound. It's not glucose. So it always has to be 6, right? So 1 mole of glucose, once again, if we see here, it's going to be canceled out. So that's gone, down. And then we're left with 6 moles of carbon on the top, which we see here. Now, it's asking for carbon in grams. So what do I have to do here? One more step. I'm going to convert my moles to grams. Now, how are we going to do that? We're going to use our molar mass, okay? So where am I getting the molar mass for carbon? Periodic table. So I understand, right, when I go and look at my periodic table, right, that it's going to be 1 mole of carbon on the bottom, cancel out there, and then I have 12 grams of carbon. Where we get the 12? Once again, I can't say it any more times than I'm saying it right now, periodic table. Okay, so we have our 12 here. Now from here, we're just going to do our math, right, multiply across, and then divide top by bottom. We're going to get 8 grams of carbon as our final answer. So this is telling me, right, that I have 8 grams of carbon whenever I have 20 grams of glucose. All right, and we can do this in 2 different ways, right? We can do it this way, conversion factors, or you could use mass percent. Both ways will give you the same answer.